All right, Ferris wheel problem. 45 meters in diameter. We're boarding on a platform that's 3 meters above the ground at the 6 o'clock position of the Ferris wheel. All right, so thinking about a clock with the numbers 1 through 12 on it, 6 is at the bottom. The wheel completes 1 full revolution in 10 minutes. Okay, so the period is 10 minutes. How many minutes of the ride are spent higher than 46 meters above the ground? Whoa, this is cool. All right, let's draw a picture. Okay, so we have a 45-meter diameter. Okay, so the first picture I think I'll draw is the Ferris wheel, and then I'll think about a function for this. All right, so let's draw my best circle here for the Ferris wheel. There's my Ferris wheel. And to get on the bottom here, that's 3 meters above the ground. So the distance from here to there, that's the diameter. That is 45 meters. And then off the ground here, we are 3 meters. All right, so here's ground level. And let's see, here's the Ferris wheel. Plotted up there. So altogether, off the ground to that center of the Ferris wheel, that would be 48 up. So that's our midline. 45 is the diameter, right? Diameter is 45. Radius would be half of that. Which would be what, 22.5. And the radius gives us our amplitude, right? How far up we go from the midline, how far down. So our amplitude is 22.5. We know what else? We have the midline, we have the amplitude. And then let's assume it just starts at the bottom. So right, our min would be 3, our max, oh no, wait a minute. Oh, I wrote that wrong. The diameter is 45. 22.5 would be the center, plus 3 would be 25.5. 48 would be our max up here. And our min would be 3. And then, yeah, that's the diameter. Let's make a note of that there. And then the radius here, that is that amplitude of 22.5. And then again, just kind of thinking about a function here. If I start at the bottom and then start counting, so graph-wise, what's this graph gonna look like? Oops. We need to get up to 48. So let's go by what? Up to 50, maybe scale by 10. So if I want 10, 20, 30, 40, 50 up there, be 10, 20, 30, 40. And then let's see, going the other way, we have a 10-minute rotation. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 1 complete period. 1, 2, 3, 4, 5 is in the middle. 3 would be somewhere down here. So we're going to start at 3 here. And we'll hit 3 again 10 minutes later. the max is 48. That's going to happen at 5, right in between. So the max is somewhere, that's 550. 48 is probably about here-ish. Our midline is 25.5, right? 3 plus the radius. So 25 is around the middle there. So about here is my midline. Choose a different color for that. So that's about the midline there. And again, if this is the min over here and that's the min, max occurs exactly in the middle at 5. And then right in between the min and the max is where we hit the midline. So that would be 2.5. So about here-ish. And then 5 plus 2.5 is 7.5. Let's make that point a little bigger. Oh, that's not the point tool. There we go. And then 5, 6, 7.5 would be around here. Okay, so this is my wave here. Go up, up, down, oops. And then what the hell? Why can't I draw that? Maybe those points aren't in the right spot. My pen is just a little off today. Both. All right, so that's my wave, and then it's going to continue to rise up and keep cycling like this. So if we were to use a sine function for this, and we could use a cosine, cosine has a max at the y-axis. Here I have a min at the y-axis, so I could just flip vertically the cosine. Yeah, that would work. So a couple options here. Let's suppose I go with cosine. I wouldn't have a horizontal shift. I would just flip it vertically to get, instead of starting at the max, to start at the min. So I think I could graph this red wave by doing y equals negative, amplitude is 22.5, cosine of, let's see, I haven't messed with the period yet. The period is 10. To get the multiplier, we compare that to 2 pi over b, the multiplier. So that gives me b equals 2 pi over 10. So b is pi over 5. So that's my multiplier to get the right horizontal stretch on this. So pi over 5. And I'm going to use x for time here instead of t. And if I flip the cosine, I don't need a phase shift. And then I just need to get it up to the right level. Midline is 25.5. So let's graph this to see if it's right, and then we'll try to finish answering the question. And let's reload, get a new window to see this. All right, so my window I drew, let's go from, let's say 0 to 20. Let's look at 2 periods. And then I want to go from, say, 0 up to 50. And I think this should be y equals negative 22.5, the radius, the amplitude, times the cosine, pi over 5, x, no shift horizontally, but I do need to shift it up vertically to get that radius plus 3, 25.5. So that should be my graph there. Let's graph the midline, y equals 25.5, see if that's in the middle. Cool. And I just want to pull this over a little bit. So I should have my minimum of 3 at 0. I should have my maximum 5 minutes later at 48. And the next min should be, yeah, those look right. And then the midline occurs at 2.5 and 7.5. Okay. Yeah, so that is the graph that I drew. And again, I was thinking about the cosine usually starts with its max on the axis. So I just flipped it by multiplying by a negative. I did a vertical flip by multiplying by a negative. You could have done a phase shift instead. Here would be the phase shift for a sine, the 2.5. If you wanted to use a cosine, phase shift would be 5. So alternately, we could do Well, I suppose I wanted the sign for this. 22.5 is still the amplitude. Period adjustment is still pi over 5. But we would have parentheses. We have to shift for the sign. We'd want to shift that midpoint of the sign over 2.5. So we would have x minus 2.5, 0.5, oops, extra parentheses, and then we add that midline, 25.5, and you can see the green sits right on top of the red there. So turn off the green, turn on the green. So there's always more than one way to come up with a function to model a situation that oscillates. All right, now for the question. So I just got it started by coming up with a model for what? What did I just graph here? Well, when I was looking at these numbers here, I was thinking about the height off the ground, right? So when you get on, you're 3 meters off the ground, you go halfway up, you're 25.5 meters off the ground, you get to the top, you're 48 meters off the ground. So what I'm graphing here is the height of an individual on the Ferris wheel versus time in minutes. And we want to know how many minutes of the ride are spent higher than 46 meters. Okay, so we have a max of 48. So we have that 0.5, 48. And we want to know when are we above higher than 46 meters. So let's graph a line. I don't know, I'm running out of colors here. So 46 would be around here-ish. So I need to figure out what is this chunk above y equals 46. So I need to find this point and this point for x values so that I can figure out what range of time, right? How many minutes are we higher than 46 meters above the ground? So this span of time right there. A couple ways to do it. One is just go to the graph and do it on the calculator, or what we do is we'll do a little algebra, which is what I'm hoping you'll try. So I want to just set this height equation equal to 46 and see what I get. So to do that, I'm going to have to subtract the 25.5 first. All right, so 46 minus 25.5 is going to be what, 20.5. Double check on the calculator in a sec. And then I have whatever's left here, negative 22.5 cosine of pi over 5 just x equals that. Divide by negative 22.5. And then arc cosine, or cosine inverse if you prefer. And then multiply by the reciprocal pi over 5. So then x should be, sorry, 5 over pi. 5 over pi times the cosine inverse of 20.5 over negative 22.5. And that should give me this first intersection point. So let's calculate that and then compare it to the graph. Did I get that 46 minus correct? 46 minus 25.5, yes, 20.5. All right, so we think, let's call this time A is 5 over pi times the cosine inverse, or you could just type arc cosine, cosine inverse of 20.5 divided by negative 22.5. Let's get this function out of the way. And I believe that's what I wrote. Let's double check. I think so. Yeah, that looks right. So this says at 4 minutes into the ride, a little over 4.3 minutes. Let's see, does that look good in my picture? Yeah, peak is at 5. I'll buy that. That's around 4.3. Sure, seems reasonable. What's the next one? That's the tricky part. So let's see, to figure out the next one, we're just going to do a little unit circle playing around. So unit circle, thinking about cosine solutions. So we had the cosine was equal to a negative number. And if I look back, this is pretty close to -1, that fraction right there. I can double check on the calculator. 20.5 divided by -22.5, -0.9-ish, right? So how would we come up with an exact value for the other one? Or any value at all besides using the calculator to do it for us? So we have cosine of some angle is equal to about -0.9-ish. Just going to go approximate. So cosine on the unit circle is an x value. So that would be somewhere over here-ish. X equals -0.9. And the arc cosine, the cosine inverse, is going to give us this angle right here for that. Now, the next one is this one down here. Let's draw that one in red. So I want to know what that red angle is right there. And the thing to think about here is that pi, an angle of pi, is right in the middle here. So to get this angle down here, again, I have that blue one right here. That blue angle is similar to this angle right there. So one way to come up with that right there would be to take an angle of 2 pi, right? Come all the way around and then back up what the arc cosine told us to get to this point right here. So I'm going to say angle 1 is the cosine inverse 0.9. And then angle 2, the next one in line here, is going to be 2 pi minus angle 1. Now, thing to think about to translate back to our problem right here, my angle that I'm talking about here, notice I don't have any pi over 5 here. So the angle I'm talking about is this whole thing right there. So when I use the 2 pi minus, I got to think about that in the context. So for my second time, it's going to be 2 pi minus my angle 1. And my angle 1 is this part right here. And then I adjust by the period. So my second angle is going to be 2 pi minus the cosine inverse of that 20.5 over -22.5. And then we adjust that whole thing with the new period by multiplying by 5 over pi. Right? That was our next step after finding the arc cosine. So that should be that next number right there. So another way to think about it, if you multiply that 5 pi through, 5 pi times 2 pi, let's actually write that down, 2 pi times 5 pi, 5 over pi, the pi's are going to divide out, and that's going to give me a 10, which was the period, minus 5 over pi, excuse me, times that arc cosine inverse, 20.5 over negative 22.5. And this one right here was my first solution. So another way to think about this is take the period when we're using cosine, sine works a little bit different, and subtract the first solution. That will give you the second solution in order, right? We played around with those in that section on inverse functions. Those are a little bit tricky, require some thought to figure out. So let's check out if that's true. So I think one solution is 4.32. That's my first one. My second solution, I'm going to call that B. I now think is 10 minus the first solution, which we're going to call, which I already called A, so I can use 10 minus A. So I think 4.3 is where one of the happens. That's just before the peak. 5.7 is just after the peak. That's where the other one should happen. So let's confirm that by graphing the line y equals 46. So this point right here should be that 4.324, nice. And this point right here should be the 5.676. And I want to know how far apart they are. So since I called them A and B here, I can just do B minus A. And so I get that we'll be above 46 meters for about 1.35 minutes. Wow, that one was a lot of work. That was fun. Way better than a cup of coffee. And again, does that seem reasonable on my picture? We peaked at 5, so we should be at 46 a little before and a little after, because 48 is the peak there. Yeah, so this one right here is about, was it 1.3, that range, about 1.35 minutes. And then for your version, things to double check here. How many decimal places do they want? Enter a mathematical expression, doesn't say, so I'd probably go more than 3 decimal points. So I'd probably go 4, 3, 5, 2, 3. And again, minutes. Woohoo, whew. That was tough.